So now we are moving over to the trig ratios. The other time we studied the Pythagoras theorem and saw how to apply it. Now, in the trig ratios, we're going to be deriving what I call that SOHCAHTOA. So, the other video we learned how to name the sides of the right angle triangle. This is a right angle triangle. So, you remember I said the side facing this box is called, that should be hypotenuse, if you remember. Hypotenuse. And this side facing this angle is called opposite. Now leaving you with the what? The last one, adjacent. Now, in mathematics, there are some ratios that are constant that we know for sure. Now, for example, you know I told you it is SOHCAHTOA. Now, meaning the ratio of opposite and hypotenuse is called sine of that angle, sine theta. So meaning sine theta is equal to this O for opposite over hypotenuse. And this C stands for cos. So we have cos theta also, cos of that your angle is the ratio of what? Adjacent and hypotenuse is equal to adjacent over hypotenuse. Also, tan theta, the T is for the tan, O and A. So that would be what? Opposite, the ratio of opposite over adjacent. So this SOHCAHTOA is just a mnemonic device that will help you remember the trig ratios. It's just a mnemonic device. So we'll look at how to use these things to solve problems, okay? Now we shall be using the trig ratios to calculate now. And look at the question, calculate the unknown sides of the unknown sides and angles indicated with letters in the figures. So you notice we have 3 triangles. We should calculate for x and y, we should calculate w, and now we should calculate the side alpha. So we use our trig ratio. And before we do that, we have to name the sides of the triangle. So 35 degrees facing here, x, so that is the opposite. 90 degrees facing 12, that is the hypotenuse. And lastly, we have the adjacent. So y is for adjacent. So if I want to calculate x now I have x there on opposite and 12, a number given on hypotenuse. So I have O and H. So I'll complete it with S. So I'll have to start with sine 35 degree, sine of the angle equals x opposite, x over hypotenuse 12, x over 12. And now we continue. If I can write this as over 1, so if I cross multiply, I'll have x is equal to 12 multiplied by sine 35 degree. So x is equal to 12 multiplied by sine 35 degree is 0.5736. So x is equal to 12 multiplied by 0.5736, that gives me 6.8832. And so x is equal to 6.9 to 1 decimal place. So x is 6.9. Okay, so we have found x. Now I want to calculate for y. Calculating for y is on adjacent, and I still have the hypotenuse there. So we have adjacent hypotenuse, so I'll complete with C, giving us car. So I'll go with cos 35 degree equals y over 12. Adjacent over hypotenuse, y over 12. Now this is still over 1, so I can cross multiply. Y times 1, y equals 12 times this, 12 times cos 35 degrees. So I have y equals 12 multiplied by 0. This will give me 8192. So y is equal to 9.8 304, and y is equal to 9.8 to one decimal place. So we are through with that. You observe. So don't forget, this is opposite. Opposite is x over divided by hypotenuse. Hypotenuse is 12. So that's that one. So we'll go over the next question. Let me erase this. So in the next question, you notice, again, we have the right-angled triangle. So we start by naming the sides of the right-angled triangle. 60 degrees facing W. W is opposite. And then 90 degrees facing R. So R is hypotenuse. And lastly, we have adjacent. So if I want to calculate W, now I have W is on opposite. This is adjacent. OA. So I have OA. And then T should complete it. So that we have 12. And I'll start with tan 60. Tan 60 degree equals opposite W over adjacent 8. Now, what is tan 60? You can write it 1.7321 equals W over 8. Now this means over 1. And also I can cross multiply. Cross multiply W times here becomes W is equal to 8 to multiply here. 8 times 1.7321. Then W equals 13.8568. And W equals 13.9. 13.9. So that's that. Now I can also solve for R. R will be adjacent and hypotenuse. So I'll use R. Adjacent, hypotenuse. Adjacent here, hypotenuse here. So it's also cos. So I'll go with cos 60. C for the cos equals adjacent 8 over hypotenuse R. And what is cos 60? 0.5 equals 8 over R. Now this means over 1, so we can cross multiply. This one times this 0.5 R equals 8. So R is equal to 8 divided by 0.5. R is equal to 16. Like that. So we come to the third one. I'm done with that. We come to the third one. Also, okay, already alpha is facing here, so here is opposite. 90 degrees facing 9. So this 9 is hypotenuse. And that's that. Leaving with the adjacent. So if you notice, 6 centimeters is here, 9 centimeters is here. So these are the two we use, O and H. And that completes with S. So we have sine alpha. Sine alpha equals opposite 6 over hypotenuse 9. So sine alpha equals 0.66667. So we need alpha. Alpha will remain here equals sine transfers here and become arc sine. Like this, arc sine 0.6667. So you can press that with your calculator, arc sine, and that will give you 41.8, approximately 41.8 degrees, just to one decimal place. Thank you. If you enjoyed this video, don't forget to like it, and you can share the video with other YouTube viewers. Alright, I will leave you with these two questions for you to try if you really understood the topic. So find the area of the shaded portion in terms of pi. So find the area. Now this is tangent to the smaller circle, and the length of that tangent is 4 centimeters. So that's it. And also here, calculate the side PB. Calculate the side PB in this triangle PBT. So calculate it. So those are the previous two things that I've taught you. And then we'll now move to sine and cosine.